Hello, good morning or good afternoon, according to the time zone. My name is Octavian Postolak, and I will present for you an interesting topic today, smart sensing system and artificial intelligence for precision agriculture in climate change era. I would like to mention that I am professor at University Institute of Lisbon, Portugal, and I am also senior researcher of Institute of Telecommunication, also in Lisbon, Portugal. We are working in a group of basic science and enabled technology. But by now, I would like to speak a few words about distinguished lecturer program. This is part of very interesting and excited program of IEEE Instrumentation Measurement Society. I am very happy to share with you some information about this program. Actually, all of IEEE members can apply one time per year. And if you need more details, the chair of DLP program, Professor Christian Donald from Missouri University of Science and Technology, can help you for this. We have here a link that can be used in order to be informed about the next competition for distinguished lecturer. And now, start with the outline of my presentation. And regarding this, I want to mention some elements about agriculture today, facts, challenges, and solutions. And moving to hot topic of precision agriculture, I'll speak about in situ monitoring of soil characteristics, remote sensing and UAV imagery, and why not, elements about artificial intelligence and application on precision agriculture. Several elements will be related to embedded AI applied in this important field of application and conclusions. Speaking about farming and climate change, actually we can first of all mention that the growth of population represents a challenge, an important challenge when we think about agriculture production and necessity to optimize the production in this field. We can mention that 9 billion people will be on the earth in 2050, and only 4% of Earth's surface is available for farming. That means an optimization procedure are required. At the same time, we have another problem about the scarce water resource that here on the map, according to the United Nations, indicate very important problem, especially in Africa, but also in other regions of the world. And based on actual problems on the earth, we can highlight two main problems: global warming and climate change. And when we speak about global warming, we can mention several elements like heat waves, drought, soil erosion, weeds, pests, plant disease, and soil salinization. And we'll see how we can manage to measure this and to avoid the effects of global warming. At the same time, we have climate change, that we have very important seasonal variation, powerful storm, torrential rains, floods, and other elements that can affect also the soil, and we can mention here the soil erosion. This change is challenging for farmers, that actually they cannot apply like regular and experience that he obtained in the past, because always the scenario is changed. And for this reason, agriculture, precision agriculture can be an important solution. Based on this, can mitigate the operation, can mitigate the yield losses, and can apply important techniques or practices like rotating crops to match water availability, to adjust sowing dates to temperature and rainfall patterns, and other important solution like to choose the best varieties. But for now, we speak more related soil and air monitoring and other way to use the data in order to, let's say, to obtain the best solution in the content of global warming and climate change. And one solution that also is promoted in European community is the digitalization in different fields, including agriculture digitalization. Digitalization is one way to reduce the climate impact of farming, allowing economic shutdown in certain regions. To do this, we are thinking in different technology, and some of them coming from IoT, smart sensor, but also developing of artificial intelligent model that can give solution for farming optimization. Inside this, the precision agriculture boosts food production, improve profitability, and reduce operational costs. If we think about precision agriculture, we have here several elements that can be mentioned. Technology and data acquisition is very important. We start from this, but based on the data, we can carry out knowledge extraction, and based on this knowledge, we can do the best planning and management of field operation. At the end of the day, we can do the evaluation and observation, and we can improve the model, and we can develop new system for measurement that can fill the gaps that was observed. The precision agriculture is using smart sensor, IoT, cloud computer. There's only few technology that can be mentioned. Precision agriculture focuses on accuracy of operation, considering the place, time to act, and method to be applied. And based on precision agriculture, we can start measuring the characteristics of the soils, like measuring the macronutrients, moisture, pH, and other parameters. This also is very important, the soil analysis, thinking about micronutrients too. If we think about 2023 trends, I can mention some very important developing direction. Internet of Things is one of them, but also agriculture, robotics, drones, satellite technology, artificial intelligence, big data, and analytics. And why not the emission reduction technology using green energy for sustainability applied also in agriculture. But let's speak about IoT, like IoT ecosystem. IoT cover different elements, starting from soil, let's say it's a smart sensor for soil characteristic monitoring, but also for air characteristic monitoring. And after this, we can mention the communication, processing, and not at the end, edge computing, fog computing, and cloud computing. Data storage, the quality of data is very important. And based on this data, applying the data science algorithm, we can create models. And based on this model, we can optimize the pesticide and fertilizer delivery for specific crops. We can speak about personalized delivery for different type of crops, but also for different type of soils there these crops are growing up. Important part is monitoring other parameters, especially weather. We speak about climate change and global warming. That means it's very important to have information in time to create a predictive models and to improve the control of production and processes. Based on this, we can diminish the production risk. But where we can apply the IoT technology, especially, and we can here mention some of the field of application. And one of them is smart irrigation. We know about scarcity of the water resource, and I already mentioned it, some extremely big problems in Africa, but not only in Africa, even here in Portugal, we can mention a big problem with water. We don't have enough rain, and we want to keep production of different type of crops like rice, where the water is important factor for a good production. Another problem is the fertilization, where we can optimize the smart soil fertilization if we cannot measure the fertilizers, the macronutrients and micronutrients in soil. How we can optimize if we cannot do a good measurement and to have a good data to create the model. Based on different techniques like imagery, we can have also information about pest control, plant disease detection in time, in short time. And we can also create models, long-term and short-term forecasting of the pest attacks based on historical data of previous year and for specific crops. Putting all the things together, we can even create good models for agriculture production forecasting. And why not about the incomes that the agriculture can deliver for the farmers. It is very important too. That IoT technology represent, like I mentioned before, a big ecosystem based on different technology. And we have here some of them and what is the impact of them in application for precision agriculture. I can mention here the short-range communication, especially Bluetooth, ZigBee, and Wi-Fi. Why? Short-range communication only to, let's say, to set up the system, to verify the system, to deploy some new firmware and so on. That it's still important to have this type of communication protocol in work. Also long-range communication, and here I can mention the cellular networks, 3G, 4G, and nowadays 5G, when the coverage is enough to apply this. And also very classical RFID, NFC, and QR code that can be associated with different equipments that are working in the field. And the smart sensor with capability to communicate each other. And here I mentioned wireless sensor network. To visualize the data, nowadays we are using mobile device, and this is very important way to transmit information to the farmer. Several studies highlight the capability of new farmers to use these devices. However, the traditional farmers are still required a specific interface with high degree with acceptability. And why not at the end, the data must be processed, and we have 3 levels of processing of computing, and I mentioned here the edge, fog, and cloud computing. Few elements about smart sensor. There are some, let's say, nowadays we speak only sensor, but actually what we are using in different devices, including in our mobile phone, it's a smart sensor. And we have here like very classical IMU, initial measurement unit, that it's including in our mobile phone, but there are other sensors that are deployed, are embedded in our nowadays used objects. And here I can mention the sensing unit that we can say sensor, signal conditioning, analog to digital conversion, and application algorithms that are implemented in embedded platform like microcontroller. And what is very important to have communication capability. The interface is not mandatory because nowadays we are using general interface like smartphone based on smartphone capabilities. And smart sensors are also characterized by self-identification, digital sensor data, smart calibration and compensation, multi-sensing capacity, and as I mentioned, sensor communication for configuration of remote monitoring. When we speak about multi-sensing in agriculture, especially, we need different, it's necessary to extract different parameters from soil and from air. And here we'll see later some, let's say, multi-sensing systems that can obtain data. Different parameters of the soil are being highlighted, like pH, conductivity, moisture, and also the concentration of macronutrients. The few words also about long-range communication that was not mentioned before. When you think about limited coverage of cellular, we have also solutions like Sigfox and LoRa to have a coverage and to transmit the data from the sensing unit, smart sensing unit, to the edge and later to the cloud computing, where the data is stored to be later analyzed and used to create new models for, let's say, predictive models or classification model, classifiers, and so on. At the same time, we have enormous heterogeneous devices that require different protocols. I can mention here some of them: HTTP, TCP, IPv6, XML, and so on, JSON. And for IoT nowadays, message carrying telemetry transport seems to win the race. We have here, very in the short, the architecture of MQTT, where we have the MQTT broker that and MQTT publisher and subscribers. And based on this architecture, we can actually receive data from different devices distributed in the field, and which can also make an interesting applications where we receive data and store data and analyze data. Let's go to smart irrigation systems. And here, the big challenge is that when we have crops with very high consumption of water, and the water consumption optimization represent always, in this case, a big challenge. Big part of crops require this high quantity of water, but not always the water that is delivering is in the right quantity. Especially even if the resources are scarce, some farmers are delivering more water that is necessary, and that means optimization can help the farmers to reduce costs and also to have a good solution for their land and to obtain good production of the crops. In some cases, where the data coming from the sensors delivered distributed in the field, like moisture sensors, can be stored and use it to create models that can be later used to automatically prescribe the quantity of water for specific crops. And here we have some models that it's mentioned the database where the data is stored. Later, based on data creation, machine learning, based on machine learning model, we can, here we have mentioned some important part, that is the feature extraction, the machine learning model training, validation, and at the end, the implementation of this model, especially in system with low computation capabilities like embedded system, that will be later presented. But the sensing must be very well related to the soil properties. That means managing the data from soil, analyzing the data from soil can be very important to create models and to act well for the, let's say, operation optimization and the optimization of the usage of research. And here, some few elements for the plant's growth: soil organic carbon, soil texture are important, soil moisture, soil pH, soil electrical conductivity, soil minerals, and here I will mention and we'll discuss this in more detail about nitrates, phosphorus, and potassium, and not at the end the light intensity, that here we can even measure, but we cannot easily control, for sure. How we can extract this information? Based on in situ measurement, but also using remote sensing. And we have here proximal sensing that can be also adapted to different equipment that are used in farming. And but also we can even consider the in situ solution and remote sensing that here can be considered mainly the satellites and airborne platforms like UAV that nowadays represent, let's say, a common solution. However, we'll discuss what is good and, let's say, what is limited on the usage of this kind of solution. Few words about macronutrients that are very important parameters. And here I can mention nitrogen that promote the growth of leaves and vegetation, phosphorus that promotes root and root growth, and potassium promotes flowering, fruiting, and general hardiness. It's very important that this we can maintain the balance of these macronutrients. And when we are doing the fertilization, we need to know what we have on the soil, on the ground, and to perform optimization of NPK delivery. Actually, the delivering of this can be also done with the drones. It also can be injected based on, let's say, together the watering for a short period. And also we can have the influence of other parameters that when we are measuring this NPK parameter, that means the concentration of nitrogen, phosphorus, and potassium. This will be also a very important to have accurate measurement of this macronutrient. How we are measuring in general, we have here the part of sensors. The sensors are can deliver directly information to the farmer. If he can make interpretation of the data, this will be a very important elements to take the right solution. The farmer can receive data also from the field, from wireless sensor network nodes, but also from mobile wireless sensor network nodes that are mounted on the level of the drones. Real-time monitoring is important, and based on this real-time, we can easily schedule the operation using, let's say, an IoT tractor. That means also have some sensing element that can also be represented by some remote sensing capability like infrared camera and so on, thermographic camera and other type of remote sensing. The architecture that can be proposed include, like here is presented, a set of in situ sensors, but also the part of smart sensor node that includes analog, digital, smart data storage, battery. We need to also think about autonomy of this system, taking into account the operation in the field, and also a part the edge computing. The edge computing can be expressed by platform, starting from embedded processing, we express it by MicroPython algorithm implemented on Arduino SP, Arduino, or other kind of, let's say, local computation platform, and wireless communication that was here mentioned, like LoRaWAN. How we can process the data, and here some solutions are appearing on the field, on the commercial field every day, and computing and data storage in some platform that are denominated like embedded AI platform. And here can also mention now the Coral platform from Google that can act, let's say, intermediate, performing intermediate computation and also acting based on the already designed models, AI models, to optimize, let's say, the watering or the fertilizer delivering. Mobile computing, it's also an important part, and different mobile apps can be developed for data visualization. And not only, also suggestion to the farmer to work in some condition. How we can implement these apps, and here I can mention some of the solution that was used by my team, and we can mention here the cross-platform like Flutter and Xamarin that give us possibility and to develop mobile app for both mobile operation system like Android OS and iOS. At the same time, the user interface layer can provide data analysis and visualization, and also in some cases also process and can be used for remote control actions. Going to the, let's say, physical layer, I will speak about one of the solutions that is commonly used for in situ monitoring of different soil parameters. And I can mention here the time domain reflectometer. It's a robust method, and it's based on the travel time of high frequency electromagnetic pulse. And at the end, what we are measuring is measuring the dielectric constant. For sure, on the back of this, we have different models that can be very useful to extract information about moisture, but not only. Nowadays, we have TDR sensors that give us information about up to 7 parameters, and one of this kind of sensor was used to extract information from different region where we make in situ monitoring. Here, a few words about the pulse that was mentioned, the voltage applied to the rods, in this case, 2 rods for the case of moisture sensor. The speed or velocity of the voltage force along the rod is related to the permittivity of the substrate, and we can, as I mentioned, up to 7 parameters. How we can, the rods size are not, it's not so big. We have working with different size, but never more than 10 centimeters, 15 centimeters. That means at the end, we need to put in the hole these kind of sensors and to, in this case, to extract information from deep soil and to use this data in order to optimize, let's say, the watering process or the fertilizer delivery. Few words about this kind of sensor that can be considered like high precision, high sensitivity, and what is very important, the durability. About the accuracy, the values that commonly are obtained are or errors for, in the case of soil, errors of measurement of 2%, yes, and we have very good resolution, and all of this depend of the range of measurement. We can see that 2% can be from 0 to 50%. When going to higher moisture from 50 to 100%, the errors are increasing, and better results we obtain from soil temperature, but the errors are less. But when we go to electrical conductivity, we go again to values of 3%. At the same time, if we're measuring NPK, that means we can reach values of errors that it's about 2% of full scale. And but it's very important to mention here some correlation between the soil moisture and the values of measuring of NPK parameters, and later we'll discuss about this. The Baroque diagram of one of the prototype that was developed in my team and is working in the field nowadays includes not only the TDR sensor, that is the XCT sensor, but also a sensor, a one-wire sensor, that multi-sensing unit, DHE22, that is a low-cost solution for air, relative humidity, and temperature monitoring. All of this, the communication with the smart sensing units is carried out by a microcontroller, the ESP32, that also include, let's say, a LoRa interface XX1278. Few elements about multi-points measurement. Actually, we implement different measuring points based on TDR, and we are using the capability of this TDR sensor to connect, to measure in, let's say, in different points using the capability or RS485. That's nowadays it's and continue to be the physical layer of Modbus industrial implementation. To have reliability of measurement, we consider also 2 nodes of air quality measurement. And what is very important in the case of agriculture, it is very important to measure the relative humidity and the air temperature. And we make some tests in in the field, and as I will mention later, in different vineries, but we start taking into account the variability of the conditions. We start to do some measurement in tropical garden. Some results was published in Instrumentation Measurement magazine. Will appear this article even this year, I hope, in maybe in October, November. And why? Because different plants here can provide different soil characteristics, and also is very important that different plants in this botanical tropical botanical garden that have some quite good extension and a good variety of the plants can give us, let's say, different condition of measurement, and also it's very important to know this in order to optimize the processes, the operation also in this type of, let's say, botanical garden. And here I can mention some correlation that can be observed between soil moisture and air relative humidity, and where the mobile application give us not only information about moisture or soil, there's also some information about the NPK concentration. What we can see here that is usually the concentration, the potassium concentration is quite always higher in all the parts that was measured. And some, let's say, results in different site of measurement. We can see here the map of the botanical garden with different measuring points that are close to some, let's say, water source and with different type of plants. And we can see here the evolution of nitrogen concentration in different places. We also, based on the acquired data, we can extract correlation between, let's say, moisture and other parameters, and we can conclude in this case that moisture parameter is very important and can affect the accuracy of the other measurement. And we are working now to create models that can, let's say, compensate this kind of cross influence. Another implementation was carried out to do work in a winery, and we work here in the different region. We have here in Ribatejo region the Lago Alva Quinta, where we carry out some measurements, and we move forward with this. And here we have the architecture where was, let's say, the prototype of level 1 that was implemented. In this case, we start with 2 nodes, but we're working now to extend this. Where what was very important was to measure the NPK concentration, and the architecture we are using also the Things Network gateway specific for this kind of network, and we are implementing the software using Node-RED technology. That provides us also to, based on the dashboard, we can visualize in real time the value coming from IoT sense. This is very important that the acquisition rate for soil parameters cannot be very high because it's not necessary. They are not changing in very short time. That means we consider here the acquisition rate at one reading in half an hour or 15 minutes. But actually, we can adapt this to the necessities. Here, few words, a few elements about interface that was carried out in Node-RED, and some, let's say, testing in each of the testing system deployed in the field. And few words about a few elements about the Node-RED environment and the implementation of this. We have here actually a few some elements about the sensor delivering information, how it was deployed, and how the data was acquired. As you can see, we have a lot of in parallel. We are using also direct connection with 485. That it's using a bridge for 485 USB, and the evolution was very interesting to make some tests about humidity, the moisture relation with the values on NPK. For very low level of moisture, actually, we cannot obtain any information about macronutrients. But when we can inject some, let's say, a specific quantity of water, we are not using more than 200 milliliter to deliver on that region, and we can actually start to obtain some information. And now we are moving to the other solution, that it's the solution based on electrochemical sensor, nowadays printed electrodes. Here is one of the prototype that was also developed in the way to extract NPK parameters. This kind of solution, it's let's say it's a mobile solution. However, the way that we apply the information, the soil on the level of the sensor can limit the usability of this solution. Here, for this kind of, let's say, mobile potential stat with capability of embedded computing, was also developed a web interface that provide us information about the different of chemical contents applied on the level of the sensor. And later we developed 4 channels, let's say smart potential stat with capability that support TinyML algorithms that give us possibility to carry out some classification of the chemical content applied on the level of the sensor. We can also speak a little bit about the flexible screen printed electrochemical sensor. That is very important for personalization. And here we can mention the electrodeposited copper for neutral detection in water. And what is very important is water, the deriving of the water, even on the level of the soil, can be very important to extract information of nitrates in this soil. Another important part is the analysis of in this case, the usage of cyclic voltammetry in automatic way in order to extract the feature that later will be used to classify and to extract the right values for the macronutrients, analyze it in soil. Here, at the same time, we can apply when we have different sensors, and the usage of some data fusion can help us to obtain better and accurate values. And here we are working in using different way on the classification. One of the way was based on can-nearest neighbor. And I can mention here an important work that was carried out by some collaborators from Chemnitz University, and here I recommend very important work of them, that it's machine learning based on level framework for hybrid voltammetric and impedimetric metal ions electronic tongue that can be very interesting, and we're working to adapt for our needs on precision agriculture. And back to irrigation, water quality measurement, another important part where the electrochemical measurement can be used is the heavy metal concentration. We know big problem that appear in the region where intensive pesticide was used. And one of the big problems, I have collaboration with some, let's say, groups that are working in India, and they are mentioning this problem and how it's working to, let's say, to measure the concentration of heavy metal. One of the solutions is printed electrode and mobile potentiometer. Here, a few words how this heavy metal can affect and which is the origin of these heavy metals. I here mentioned it, and but the more important, we can see that some of them are coming even from pesticide and fertilizer, and the usage of reduced quantity of pesticide can improve and can avoid the heavy metal delivering also in water, that contaminate the water that later is used to watering the fields. How we can, the testing of electrochemical methods, here in the case of heavy metals, we can use also different amperimetric analyzing altimeter, and we can detect very low heavy metal concentration, thinking that we need to detect ppb concentration, not ppm. That means it's very low concentration, even in water, contaminating, but even with ppb concentration that affect a lot the life of the people and animals. If we're thinking about different channels, well, we can have some implementation where different set of printed electrodes are making in a flexible support or an extended support. And in this case, we can extract at the same time information from different type of compounds, chemical compounds. Commercial solutions are here also with Bluetooth communication and also already interface with the interface embedded. However, in our case, we're using the mobile phone to obtain the data from this kind of. And now we're going to remote sensing in the last part of my presentation. And remote sensing can have here ground sensing, aerial remote sensing, and satellite image was already mentioned. And if the green seeker is one of the solutions that can be used to calculate and normalize difference vegetation in. That is very important, also used in satellite observation. Based on this, we can observe illumination intensity, target temperature, and sensor body temperature. It's very important factor that can affect the NVDA. And based on this solution, we can identify not only, let's say, temperature stress and water stress, also can identify pest disease and wets. Detect water stress, as I mentioned, and based on this, we can optimize the irrigation process. We can, based on this remote sensing, we can create water stress maps, and we can deliver, let's say, in the right way, where we can identify especially water stress, not to deliver water everywhere in the field. That can give us possibility for water optimization. At the same time, we can have information about we can have also very well distribution of fertilizer. And in this case, we can, let's say, reduce the impact of high quantity of fertilizer delivery. That means higher cost, and the higher cost of operation, not only of the fertilizer. The UIV is the way to deliver, in some cases, of fertilizer, but also to extract this image for an extended region, more larger than the case of the usage of remote sensing embedded on the equipments. Important component of UAV, and we're using some of this, let's say, multispectral camera. That means we can have image from different range or spectral range, combining infrared, red, green, and blue light imagery. And we can have always normalize the different vegetation in the distribution for, let's say, monitored region. How we can process this data, and according to the type of multispectral camera, and here I mentioned the particular case of DGA-P4 that is used in our case, we can use Windows SDK, onboard SDK that are supported by DGA Terra. Here you can have also other elements like PX4D capture. They are different. It's a DGA platform for provide a set of PXA4D application that can be very useful in order to extract information from acquired image. And the applied application of artificial intelligence can give advantage of precise and efficient farming. And we have here like satellite imagery, Google Earth Engine image, and Jupyter Omdena built-on app for crop yield prediction. And some example of this application can be observed in different regions of Africa, particularly in Senegal, where some results, very good results, was obtained. And AI can enhance productivity and resource management, as was mentioned before, through the well delivering of water and nutrients. It's the more development area of AI application was mainly in water management, taking into account that this is one of very important resource, and also the scarcity of this resource, let's say, dynamize the AI modeling and AI application in precision agriculture. Based on these AI models, was created specific commands from different type of irrigation, and here I can mention some of them. Sprinkler irrigation, and also we have center pivot irrigation. Models must be adapted to also to the type, control to the type of wire irrigation, and also we have drip and micro irrigation, where AI can be applied to precisely control the amount of water to be applied for specific crop. Here we have actually an architecture of this, let's say, applied AI for water delivery, where you can see a different way to extract the information. The delivery of the data through the can be LoRaWAN gateway to the cloud server, and after this, the model training and delivering of the control commands through the watering, different watering solution. At the same time, it's very important to extract other elements that can go from soil characteristics to the farmer decision at the end, to the, let's say, to the final results obtained for a specific role. And the models are based usually, as I mentioned before, machine learning, but also nowadays taking into account the remote sensing, another way to implement its deep learning. And here we have some architecture of, let's say, deep learning architecture based on convolutional network, where the big advantage is to automatically extraction of the features compared to the machine learning implementation. Some few elements about how we can use how we can implement. Here we have a set of libraries that can be used, and I can recommend here the TensorFlow and Keras in the case of the deep learning implementation. Few words about where we can implement AI. One of the solutions is to go on the edge. And here, what we can guarantee, high performance, energy efficient, private, and fast. And the compute power that runs locally can be very important. I can mention few words here and few solutions and compare. It's one of them is based on Android of Arduino, and nowadays we have Arduino developed some TensorFlow-like that can be used. It's also one of, let's say, nowadays classical NVIDIA the Jetson Nano and Google Coral board. Few words here that based on TinyML, we can actually create the model, and we can deploy it after this on the level of very low computation platform like Arduino. Okay, and conclusion: growing population, climate change, and global warming requires an extended application of precision agriculture in 21st century. Taking into account, let's say, like I start with global warming and climate change, ecosystem for agriculture 4.0 with distributed smart sensing, data communication, fog, and cloud computing provide us very good solution. And but we need to work more about the acceptance by the farmer of this solution. And I can mention here, like digital agriculture, literacy challenge is an important one. And the usage of AI, and particularly machine learning model, can go to customized solution for smart farms. AI models can relate water and macronutrients delivery in with plant illnesses and pest attack. That can avoid the number of, let's say, illnesses and pest attack. Thank you very much. Now I want to see here, we have some. We have here, thank you, Kim Fuller. I'm very happy to hear you. Christy, yes, we have here a question. How do you see the connection between intensive smart farming and food quality? Yes, it's a very, very interesting part. Very, very interesting. The food quality, it's another part that we can develop after when we consider the smart sensing solution and AI. But nowadays, the way that the delivering of, let's say, pesticide and the delivery of fertilizer based on optimization, we can even use less pesticides and less fertilizers. That means we are going for, let's say, more bio production. That in this case, the food quality will increase. Optimizing the operation, we can obtain better results with less, let's say, the usage of different pesticides, and we can have better production. I think that precision agriculture can give solution for this too. Thank you, Jose. I have here another regarding in situ calibration. This is also very challenging situation. In situ calibration, according to the solution that we mentioned before, can be actually in the past, we already work together for other kind of solution for environment water quality in situ calibration. That means involve the usage of different the system with and actuators like pumps, and also some calibration solution. However, normally we consider that the calibration for the, let's say, printed electrodes and so on can also carry out with some set of micropumps, and we are working to develop some solution in this way. Hello, Pilar. Okay, glad to meet you again. It's very interesting questions, as I mentioned. According to TDR and delay reflectometry, we see that this kind of sensor are measuring like macronutrients, but it's very dependent on how the moisture of the soil is, and it's necessary we can measure the macronutrients when the humidity is up to normally 10%. If we have less, this is normal, because if we have less humidity, less water in the soil, actually we don't have ions of NPK. We have some salt of this. And if we're using water, we can, let's say, the covalent connection will be broken, and we'll have, in this case, ions that we can measure. That means if we want, our work now is to see how we can optimize and to obtain better accuracy in the field using less amount of water. Hello, Zahar. I'm very happy to meet again. What is future prediction of the field? Okay. The future. Okay. I'm not future prediction of the field, or I don't know exactly how I can interpret this, the future prediction development in the field, or I don't know exactly, but if we think about prediction of the crops obtained in the field, we can we can act based on the data coming from the smart sensor, not only in situ monitoring, but also wavy remote sensing, and also satellite. And we consider that the calibration of image based on in situ is a very important part. Hello, Vo Hang Tang Chao, glad to hear you. Yes, I'm working in this moment with some friends in India that are, let's say, have a very interesting initiative for the equal agriculture, that trying to help farmers with less possibility. We speak about farmers that are working on the surface still 4 hectares to have their own solution, especially to implement let's say, a process like watering optimization and also fertilizer delivery. I think that good solution can be applied. Or I have a PhD student from Africa, from Mozambique, that also very interested in this thing, how we can adapt to can be adapted for different conditions. Nirmal Pogari, Punjabi, hello. Yes, this was the idea to develop solution for small farms, to help farmers to better health. Yes, especially we are thinking about the watering that can be easily implemented, but also we can speak about also is very important solution, robust solution that can give us some information about other parameters of the soil that can help the farmers to choose the right yield for the right period. Yeah, say that above statement is a viable solution. Well, I speak with Wu Hong Chang Chao. Thank you for the questions. Is a viable solution? Yes, actually, we if we consider it's not only the sensing part, but also the adoption of the digital part, the interaction with the sensing system through the mobile application and so on. Nowadays, even the farmers are commonly user of the mobiles. It's true that in some cases it's less used in some region of the world, but even in the very, let's say, low-income countries, the people are using mobile phone, and I think that even for the farmers will be the solution to receive data, to have the analysis of data with, let's say, low cost or free of cost software, and later to use for to deliver to optimize the solution. Hello, Saba, Mila Rahman. Great to hear some, let's say, your words, and I will be very glad to answer you. Many thanks of interesting overview of the current development PA using latest innovation, AI, and so on. DGE Mavic multispectral cameras mounted on drones are used as part of advanced and productive package of tools to individuals and organizations engaging in precision worldwide. Your views on this? Yeah, the DGA, it's UAV and the software that was mentioned. It's, let's say, have a very important contribution to extract information. However, I'm sure that will be this step of remote sensing based on UAV is less appropriate when we speak about smart farming and small farmers. And however, we think that the UAV cost decrease every day, and we can, and also the tools that are available increase the quality, and that means can be used to extract better information about, let's say, crops characteristics in a remote way, and that can be helpful to optimize the processes. That means I believe that in the near future we'll have even lower cost. That means will be affordable for the small farmers that was here mentioned. Thank you. Okay, grateful to Manuel. We met 2 months ago in Kuala Lumpur. All the best to Manuel. Simon, Kivan, Oko, thank you. Thank you. Great to hear you from Congo. Can we detect amount of pesticides used applied? It's very, in the way, the solution that was mentioned before can use the case of, let's say, a printed electrode specific functionalized printed electrode, yes, can be used to detect pesticide, but it's and also in some way the amount, but how much pesticide to apply, for instance, it's not an easy way. That means this depends a lot about the crop type, about how it's affected for different and different conditions. Vo Hong Tang Chao. Moisture sand can be worn for a long time measurement. Yes, I fully agree. On the sand, it depends. Yes, depend of the technology that you use for the moisture sensor. We speak about maybe if you think about resistive one, yes, I fully agree that in time will be affected. However, the more robust I consider the capacitive based sensor, and also, like I mentioned before, the TDR sensor. Well, hello, Simon. I'm very happy to hear from you, and I'm very happy to give collaborate with you and your team in the future. Yeah, this is a very important point. Zafar, Tagvi, very nice questions. You're right. The using IoT, it's always we are can be affected, our IoT solution, by cyber attack. One of the solution is to try to use the embedded AI and to store and process data in the field, and to avoid the transmission of, let's say, raw data along the network. In the cyber security. The cyber security is an important issue for this kind of network. But this issue is not common only for agriculture; it's also for industry, and that means I believe that the development in the near future will help us in the industry. We can to deploy some, let's say, secure solution also in precision agriculture. How do we have here Sariba Yadav. Thank you for this information. Is any work going to develop of sensing matter for electrochemical sensor? How do we select particular COIG strip nutrient detection? Will synthesizing new material in process your group is currently working? Here, what I can, we are collaborating with a group from Chemnitz. They are doing, and another group that develop printed electrode. Actually, we are developing more part electronics, analyze, and communication. And if you would send me an email, I can deliver you a contract from Germany, where they are functioning different solution, and they are interested too in developing of new sensor in this field. Actually, we are working in collaboration, as I say, with two groups that develop this kind of sensor. We develop our let's say mobile potential start and so on. We are working together. Within the weather, again, Safar, head, cold, rain, shifting of the environment. How can the farmers be advised for future forming trends? Rain at different places at different times. heat and cold. Yes, it's we have a different way. That means we can use different source of data, not only data that we can obtain from in situ measurement, but also we can put together when we create models and prediction, data coming from a meteor station, and we can also have like historical data. And for this reason, we can deliver information in time that we predict for some period of time, some, let's say, information in time that can help people to operationalize, to operate in the good way. And Manuel Alvarez Herrera, hello. Okay, thank you very much. I wanted to extend my heartfelt thanks for the insightful task you shared with us. It was truly enriching. I have technical question. Would it be possible to use solar layering on embedded board responsible for sensing? I would love to hear your opinion on that. Actually, the models, the embedded solution, the models that we can implement on these embedded platforms are quite, let's say, limited, the type of the models. However, if we think about the platforms like NVIDIA Jetson Nano, we can consider that to use also this to implement this mentioned algorithm. Personally, I didn't use this, but you can try to with this platform that was mentioned here. I think that I answered to all the questions. Thank you very much for your time. And we hope that we meet again, who knows, in different conference or maybe working together for some project in this exciting field. Thank you very much for all. And thank you very much. And have a good day or night.